There is something rolling through the deserts of northwest China right now, and the moment you see it, something in your brain says that should not be possible on wheels. One single moving part of this machine weighs 32 tons. Its main arm stretches taller than a 60-story skyscraper. The counterweight holding it in balance outweighs the entire Statue of Liberty, base and all. And when this thing is done with a job, it folds itself back down, pulls onto a public highway, and drives to the next site, past gas stations, through traffic, like a truck. Just a truck that happens to be the largest, most powerful wheeled crane ever built in the history of this planet. This is the Zoomlion ZAT 400H, and by the end of this video, you are going to understand exactly why China built it, why no one else did, and what it means for the future of energy for all of us. Because the crane is just the headline. What is happening behind it is something else entirely. Stay with me. This one gets wild. Welcome back to AK Truthix, where we do not just report the story, we go underneath it. Today we are talking about a crane, and I know what that word does to people, but before you even think about scrolling, understand that what Zoomlion built is not a crane in any sense you have encountered before. This machine was created because a problem existed that no piece of equipment on Earth could solve. So China's engineers spent years designing something from scratch that could. 4,000 tons of lifting capacity, a boom that reaches higher than most city skyscrapers, a counterweight outweighing the entire Statue of Liberty, base and all. And when this thing is done with a job, it folds itself back down, pulls onto a public highway, and drives to the next site, past gas stations, through traffic, like a truck. Just a truck that happens to be the largest, most powerful wheeled crane ever built in the history of this planet. This is the Zoomlion ZAT 400H, and by the end of this video, you are going to understand exactly why China built it, why no one else did, and what it means for the future of energy for all of us. Because the crane is just the headline. What is happening behind it is something else entirely. Stay with me. This one gets wild. Welcome back to AK Truthix, where we do not just report the story, we go underneath it. Today we are talking about a crane, and I know what that word does to people, but before you even think about scrolling, understand that what Zoomlion built is not a crane in any sense you have encountered before. This machine was created because a problem existed that no piece of equipment on Earth could solve. So China's engineers spent years designing something from scratch that could. 4,000 tons of lifting capacity, a boom that reaches higher than most city skyscrapers, a counterweight outweighing the entire Statue of Liberty, base and all. And when this thing is done with a job, it folds itself back down, pulls onto a public highway, and drives to the next site, past gas stations, through traffic, like a truck. Just a truck that happens to be the largest, most powerful wheeled crane ever built in the history of this planet. The answer takes us somewhere most people never think about. Number 1. Why the desert needed a monster. The Gobi Desert in northwest China is not the kind of place you picture when someone says desert. No soft golden dunes, no gentle breezes. This is a hard, sun-scorched, wind-blasted stretch of earth where temperatures swing from brutal heat in the afternoon to bone-chilling cold before sunrise. Almost no population, very few roads designed for heavy machinery, and the wind, it does not gust occasionally. It blows hard and steady nearly every single day, all year long. That wind is exactly why China sent an army of engineers out there. China has the largest energy demand on Earth. For decades, coal powered the majority of it. Expensive, dirty, and China made a deliberate decision years ago to change that. One of the biggest pieces of that strategy was simple on paper. Go to the places with the strongest, most consistent wind on the continent and build wind farms so large they are visible from space. The Gobi and Xinjiang desert regions are almost perfect for this. Wind out there is not occasional, it's structural. Constant, reliable. Wind turbines convert that kinetic force directly into electricity. The blades spin, a generator at the top turns that rotation into power. Cables carry it hundreds of kilometers to cities, homes, factories. No fuel burned, no emissions, just moving air becoming electricity. Here's the problem nobody talks about. The taller a turbine gets, the more physically impossible it becomes to actually build. To install a turbine at 170 meters, you need to lift a component called the nacelle, the heavy metal housing holding all the working parts. 150 tons of it, straight up, 170 meters into the air. Then you need to attach 3 blades, each 108 meters long, at that same height. Longer than a football field. No crane on Earth could do that. City cranes can't reach. Crawler cranes are too slow, destroy the ground beneath them, and take months of logistics just to position at a remote site. What the Gobi needed was something that could reach 186 meters into the sky, carry enormous loads at that height, drive on public roads, set up fast, and handle rough desert terrain without sinking into it. That machine did not exist, so Zoomlion built it. Number 2. 2,000 kilometers on wheels. Here's where the story starts to bend your mind in a different direction. You've just finished building the largest wheeled crane on the planet, a boom that reaches higher than most skyscrapers, a counterweight heavier than the Statue of Liberty, and now you need to move it 2,000 kilometers across China to a construction site in the middle of the Gobi Desert. How does that even work? It doesn't travel assembled. The crane is broken down into hundreds of separate components, loaded onto individual transport vehicles, and moved as a convoy. The full convoy is 28 vehicles rolling together. When that line of flatbeds and carriers is moving down a Chinese highway, it doesn't look like a construction delivery. It looks like a slow-moving city. This monster can share a road with a Honda Civic, and the road does not notice. When the convoy finally arrived at the desert site after 2,000 kilometers, roughly New York to Kansas City, everyone took a breath, because now came something nobody had ever done before: assembling all of it in an open desert with wind pushing against everything. And here is the detail that puts the scale in perspective. Assembly requires smaller support cranes just to lift the pieces of the large crane into position. The crane is so large, it needs other cranes to help build it. The slewing platform went up first. 2 support cranes worked in tandem to hold that 65-ton circular base in position while the main crane body slowly moved underneath. Engineers had to align 2 perfectly round platforms in mid-air, while desert wind worked against every measurement. When the hydraulic pins locked them together and the support cranes released, it clicked. Solid. The boom came next, built from 7 separate sections. In older crane designs, this meant workers in the desert sun swinging sledgehammers, driving steel pins through connection holes by brute force. The Zoomlion uses hydraulic cylinders. The sections align, the system pressurizes, the pins slide in cleanly. No sledgehammers, no bruised hands. Section by section, the boom rose. Cables threaded through pulleys, hydraulic lines joined system to system. The machine was waking up. The final piece was the superlift wings, 2 enormous arms extending from behind the crane like the wings of a giant steel bird. They carry the counterweight that prevents the crane from tipping forward under a heavy load. When those wings spread to full span, the crane stops looking like construction equipment. It looks like something from another world. For the turbine installation ahead, 260 tons of counterweight was loaded onto those wings. And here is the number that reveals just how capable this machine is. 260 tons was not even close to its maximum. The turbine job barely pushed it. Number 3. The lift that changed everything. The day the crane stood fully assembled, the team stopped and looked at what they were about to attempt. They were in the Gobi Desert, hundreds of kilometers from the nearest large city. In front of them, a tower rising over 170 meters, assembled over multiple days using 3 separate cranes working in sequence. A 900-ton crane placed the concrete base ring. An 1,800-ton crane handled the middle sections. Now, the Zoomlion had taken over for the top, because nothing else on the site could reach that high. The first test was the nacelle, over 150 tons, needed to travel from the desert floor to the top of a 170-meter tower and land precisely on an opening that's only so wide. One shot. Before the nacelle left the ground, workers attached rope lines to all 4 of its corners. 4 separate teams, 1 on each side, holding those lines from below. This was not procedure for show. A 150-ton nacelle hanging from a crane cable at 170 meters behaves like an enormous pendulum. If wind catches it up there and it begins to swing, the momentum of that much mass in motion becomes catastrophic. The rope teams were the human counterforce to that physics. The crane provided the lifting power, the people provided the precision. But the hardest part was still ahead: the blades. Each one is 108 meters long. Let that actually land. That's a football field from end zone to end zone, plus the full width of an end zone added on top. These blades are built from lightweight composite materials, which sounds reassuring until you realize each one still weighs around 30 tons, and there are 3 of them. Getting a single 108-meter blade to the desert site was its own operation. The transport vehicle has an extendable frame, front and rear separated by dozens of meters to support the blade flat and stable. In open highway this works, but reaching the turbine site meant mountain roads, tight turns, steep grades. An extended frame cannot navigate tight mountain curves. So the team shortened the configuration, which created a new problem immediately. When the blade sits on a shorter frame, a large portion overhangs past the front axle, acting like a lever. The more weight hanging off the front, the more the rear of the vehicle wants to lift off the road. A transport vehicle losing rear traction on a mountain road while carrying a 30-ton blade is not a problem, it's a catastrophe. The fix was direct: make the vehicle heavier. The team added ballast until the total vehicle weight hit 160 tons, keeping the rear planted firmly on the road. 3 support vehicles stayed on standby throughout the entire transport, ready to intervene at any moment, day or night. When the first blade finally reached the site and the team prepared for the lift, the wind came in. Strong, steady gusts rolling across the desert. A 108-meter blade hanging in strong wind doesn't stay still, it becomes a sail. The crane lines twist, control disappears, and a 30-ton sail swinging at 170 meters in the air ends the project and likely ends several lives. So the team waited. They set the blade down carefully and waited through the afternoon. The wind kept blowing. They waited through the evening. Workers settled onto the desert floor as the temperature dropped. Some stared at the stars. Some tried to sleep. All of them watched the flags and weather instruments, waiting for the numbers to change. Then, just before dawn, the wind dropped. Not gradually, quickly. The way desert air sometimes goes completely still in that brief window between deep night and sunrise, as if the atmosphere pauses to take a breath before the new day begins. The call went out. Everyone moved at once. The first blade went up in the dark. Lines tightened. The blade lifted clear of the ground. Rope teams grabbed their lines and walked with it as it rose. A 108-meter wing tilted against a sky just beginning to lighten at the horizon. Higher and higher. Operators watching instruments. Engineers calling measurements over radio. Teams working their lines in the cold pre-dawn air. And then, as the first trace of sunrise touched the horizon, the first blade locked into place at the top of the tower. A machine built to catch wind, installed in a rare moment when the wind went still, as if the desert itself paused to let the work get done. The second blade went up without incident. The third required 3 loaders pulling it up the final mountain section from the front, while the carrier climbed from below. When the last blade locked into place, it was done. 170 meters tall, 3 blades, each 108 meters, standing in the Gobi Desert, ready to spin. Number 4. What this actually means. It's easy to come away from all of this thinking big crane, impressive engineering, cool video. But what you just watched is a turning point, and here's why that matters beyond the specs. Before this crane existed, there was a hard ceiling on how tall a wind turbine could practically be installed on land. Engineers had the designs, they had the math, they had the material science for turbines standing over 160 meters. What they didn't have was a crane that could build them at remote terrestrial sites. The Zoomlion broke through that ceiling. The latest version can reach turbine hubs at 190 meters and handle 7 megawatt turbines without a secondary large crane. It sets up faster than anything in this category ever has. It drives itself between sites on public roads, slashing the downtime between installations. One project manager reported that using this machine eliminated secondary crane outsourcing entirely, saving the equivalent of millions of yuan per site in coordination costs alone. Multiply that across across hundreds of turbine installations a year across China. Then multiply it across the global wind industry, which is watching all of this very carefully. Europe, the Americas, Southeast Asia, every major wind market is facing the same ceiling. Turbines need to go taller, and the cranes haven't kept pace. China just showed the world what keeping pace looks like. But the piece of this story that gets lost in all the numbers, out in that desert, there were people. People who drove 28 vehicles across 2,000 kilometers of China. People who assembled this machine piece by piece in desert wind. People who climbed to the tip of a 186-meter boom to thread steel cables through pulleys with the entire desert spread out below them like a map. People who grabbed rope lines in the cold dark before dawn and held a 150-ton steady as it swung far above their heads. People who sat on the desert floor through an entire night, watching the stars, waiting for the wind to stop. The crane is the headline. Those people are the reason the headline happened at all. So here is where we land. China built the largest crane on wheels in history, drove it 2,000 kilometers across the country, assembled it in a barren desert, and used it to install towers taller than skyscrapers that will power hundreds of millions of homes without burning a single drop of fuel. The scale of what is happening out in those deserts is genuinely difficult to hold in your head all at once. But it leaves one question on the table, and I want your honest answer. Is China doing all of this because it genuinely cares about the planet and the people on it? Or is this the most calculated strategic move in modern history, building the infrastructure that lets China own the global clean energy market for the next 50 years while everyone else scrambles to catch up? Because those are two very different things, and your answer changes how you feel about everything you just watched. Drop your real take in the comments. No right answer here. This is one of those conversations where the debate itself matters, and I want to read where you actually land. If this video opened your eyes, hit like. It helps this channel reach more people who would never expect to get completely hooked watching a crane video, and absolutely will. Subscribe so you don't miss what's coming next, and share it with one person who thinks they already understand how the world works. I'm AK. Stay curious, stay truthful. See you in the next one.